Okay, so solving trig equations. Let's take a look at some examples here of what I'm talking about. So let's say that you were asked to solve for all values of theta, then give only the values of theta between 0 and 2 pi. Okay? All right, so let's say you have a problem like this, and it just says tangent of theta equals 1. Tangent of theta equals 1. So we're not trying to do anything except figure out what angle theta makes this true. The problem with this is there's lots of answers that make this true. Okay? For example, here's kind of what we're talking about. Imagine a tangent graph, right? How many of these pieces are there? How many of these little branches are there? Infinite number, right? So this just goes on forever. We're trying to find basically where this is 1. Well, that's going to happen all the time. You know what I mean? We're going to have 1 more than once. It's going to happen so many times. So we're going to try to give all possible answers. Okay? Most people don't look at the graph to solve these. They look at the unit circle. Okay? So can you think of an angle somewhere on the unit circle where tangent is 1? 45. Okay, so we'll call it pi over 4 if you don't mind. Where's another space on the unit circle where the y and x coordinates are exactly the same? So when you divide them, you get 1. Right here, right? At 5 pi over 4, these two spots, if you look at their coordinates, when you divide their coordinates, they come out to be 1. Okay? So this is root 2 over 2, root 2 over 2, so the ratio is 1. And this is negative root 2 over 2, negative root 2 over 2, so the ratio is 1. So the first answers that come to my mind are pi over 4 and 5 pi over 4. But these aren't the only ones. We know that if you go a full circle from pi over 4 and you wrap all the way around the circle again, that's going to happen again. Right? So if you add another 8 pi over 4, that's another 2 pi. At 9 pi over 4, for example. If you type 10, 9 pi over 4, it'll say 1 9 pi over 4. So what I'm saying is all the angles coterminal with this work, and all the angles coterminal with this work. So what we're going to do is add on to this a 2 pi k. So let's add 2 pi k right here. This just means that we can add 360 as much as we want. Okay? All right. These are all the possible answers. If you want only the answers, because there's a second part to this, if you want only the answers between 0 and 2 pi, then just give the pi over 4 and 5 pi over 4 answers. These are the answers on the interval 0 to 2 pi. Okay? Because they ask for 2 answers to this problem if you read the instructions. Okay, now some students are very clever. Okay? And they'll say, Mr. Shore, why are you doing 45 plus 360 and 225 plus 360? Why not just call it 45 plus 180? You know what I mean? Why not just go like 45 plus 180k? Because then that would be 45 plus 180, 45 plus 180 2 times. So some people like to compress these two guys into one simpler answer, pi over 4 plus 180k. That just means pi over 4 plus every half term from that point on. So I'm actually going to do that. I'm going to go ahead and write this answer in a little bit more simplified form. You can just write
theta equals pi over 4 plus pi k. Now sometimes I can't think of a very clever way to re-express my multiple answers into one tidy little purple equation, but sometimes I can. And with tangent, it's actually pretty easy to create. This is a tangent problem. It's pretty easy to create a simple one like that for a final answer. Okay? So try to do that with tangent. See if you can get it down to one simple little thing like that. Okay, let's go on to another example. All right. So the second example I picked was same instructions, so if you don't mind, I'm not going to rewrite them. It's just cosine of theta equals negative root 3 over 2. So you kind of need to know your unit circle well. There are two angles on the unit circle that qualify for this. They're both, of course, on the left, because x over r has to be negative. And they are at 5 pi over 6 and 7 pi over 6. They both have an x-coordinate of negative root 3 over 2. So those are the first two that come to mind. So we'll just write 5 pi over 6 plus, and don't forget the 2 pi k. That just means all the angles coterminal also with 5 pi over 6. And 7 pi over 6 plus 2 pi k. These are all possible answers to the question. If we are only to answer between 0 and 360, then we'll just give these two. Only. So we would say those are the answers on the interval 0 to 2 pi. The reason I'm doing two sets of answers for everything is because sometimes in the book they ask you for a general formula for all answers. That's this. Sometimes they say give all answers from 0 to 2 pi. That's this. So I want to do both each time. That way you can get the hang of it. Okay, these get a lot harder. So I'm just building slowly with this. Let's go on to a third example. Okay. You guys ready? Okay, here's example 3. Example 3 is, same instructions, sine 2 theta equals negative 1/2. It's getting harder. Okay? So you do not want to divide by 2 here. You can't do that. Okay? And you can't use like one of our identities. You know how we have the sine 2 theta identity? We're not doing that either right now. We're taking a break from identities a little bit, okay? All you're trying to do on this is understand that 2 theta has to be 7 pi over 6. Write that a little bit neater. 7 pi over 6. Or the other possibility is 11 pi over 6. Why? Because this is first and foremost a sign question. See, it says right here, sine of something is negative half. See? So you're supposed to be thinking about sine right now and where it is negative half. And it's on these two spots on the unit circle where sine, the y value is negative half. So the first thing we do is we just kind of ignore the fact that this is 2 theta and we just say, what angles have a sine of negative half? That's these two. Don't forget the 2 pi k. Those are the coterminals. So everybody say 2 pi k.
2 pi k.
Say 2 pi k. Some of you are really good at that. Okay. So these are our two answers. We're not quite done. We need to divide by 2. Okay, because we wanted theta, not 2 theta. So if we divide by 2, so basically divide by 2, here's what we get for a final answer. Theta equals 7 pi over 12 plus pi k, and what happens when you divide 11/6 pi plus 2 pi k by 2?
Pi over 2k.
We're going to divide this by 2 and divide this by 2. So this will become 11 pi over 12. This will become, no, you say okay. Okay. Right. I say it right. Okay. So it's 11 pi over 12 plus pi k. If you're asked just for those angles that are between 0 and 360, then you just give the 7 pi over 12 and the 11 pi over 12. Those are the answers from 0 to 2 pi, in case they ask it that way instead. All right, any questions so far? So that one, I looked first at the unit circle, then I divided by 2. And don't forget the 2 pi k. All right, let's go on to the next example. Tan theta over 2 equals 1. So every year I see a student or two take this thing and turn it into an identity problem by doing something like this. They'll take my problem, they'll say, oh, this is like 1 minus cosine theta over sine theta equals 1. You just made your life really hard. Now you've got two trig variables to worry about, sine and cosine. That would be the right idea on a 6.5 question, but this is 6.7. Different topic, different day, okay? The goal is to find the missing angles. Like, what angles make this work? Well, I can tell you right now that 90 degrees works great, right? Because if I put a 90 right there, this is tan 45 equals 1, which is true, right? Okay, but if you start thinking that way, you're going to start getting some of the many answers and not all of them. So what you probably want to do is ignore the fact that it says theta over 2. Just don't even look at that. And just ask yourself, where have I seen tangent equals 1? Well, we did this a minute ago. Where was it again? Here and here, right? All right, yes. Okay. So pi over 4, 5 pi over 4. So theta over 2, that's the angle here, inside the tan, is pi over 4, or pi over 4 plus 180. So this is just on the other side of the circle. So I'm not going to write both of these. I'm just going to put a pi k here. That will take care of the 5 pi over 4 anyway. So I'll just put plus pi k. What does that mean, plus pi k? It means plus any multiple of 180, which includes that 225. Okay, so I'm just going to make a little note here. With tan problems, you only need one answer from the unit circle if you put plus pi k. If you put plus 2 pi k, then you're going to need to put both answers down. So that says plus pi k there at the end. All right. I would like to now simplify this. So I'm not quite done. I'm supposed to get theta. Right now I have theta over 2. So what do I need to do to get the theta by itself? Double it. Right. So doubling both sides gives me pi over 2 plus 2 pi k. These are all the angles in the entire universe that make this statement true. The original equation. And if you want just angles on 0 to 2 pi, then you just go with pi over 2, drop the 2 pi k. All right. Let's go now to example 5. I told you it's going to get harder, okay? So here goes. 4 cosine squared of 2 theta minus 3 equals 0. This is a fairly challenging problem. Okay? First of all, I'm supposed to isolate the theta eventually, but I got a lot of junk on the left side. This needs to be cleaned up. So the first thing we would do is add the 3 over. Okay, so now it looks like this. 4 cosine squared 2 theta equals 3. Then we would divide both sides by 4. We're trying to work from the outside in to free up that theta. So now we have cosine squared 2 theta equals 3/4. But now I need to square root, right? So when I square root, I can't forget the what symbol? Plus or minus. Square root of 3, I don't know that. Square root of 4, that's just 2. Ooh, this looks very familiar. Root 3 over 2. That thing's all over the unit circle. I can think of several angles that qualify here. I think 2 theta could be 30 degrees, power 6. I think 2 theta could be 5 pi over 6. 2 theta could be 7 pi over 6. 2 theta could be 11 pi over 6. Why so many answers? Because we are allowing for cosine to be either positive root 3 over 2 or negative root 3 over 2. Either way. See? So that opens up a whole can of worms. These are all possibilities for 2 theta. And they each get their own little 2 pi k. So let's say 2 pi k. Because I don't want you to forget about it. You got to add it on here. So plus 2 pi k plus 2 pi k plus 2 pi k plus 2 pi k. All right. Not done yet. We need to divide by 2. All right, so what are my answers if I divide by 2? Theta equals what? Pi over 12 plus pi k. 5 pi over 12 plus pi k. 7 pi over 12 plus pi k. And 11 pi over 12 plus pi k. If you ever get lost, okay, and you can't remember what you're supposed to be doing, or you're getting really confused by the pi k's and the pi's and everything's just messing with your brain, just switch to degrees. We're talking about 15 degrees. We're talking about 75 degrees. See? We're talking about, what's 7 times 15? 105? Is that right? 7 times 15? Robin's nodding, so I'm thinking that's right. Okay. 11 pi over 12, it's 11 times 15, 165. And this is just like a little plus 180k here. So if radians tends to twist your brain a little, I understand. Just think, oh, it's these angles here. And just do everything in degrees. That's fine. You can always change it back to radians when you're done with the problem. So there are 4 possible answers here. Infinity possible answers if you count all the 180k's going on. Okay, so you can write your answer like this if you wish. Or like this. I will say you need to kind of get used to radians because that's kind of the way it all ends up in the end. Nobody uses degrees in calculus. So, what about answers that are only between 0 and 360? Got to be careful here. There's a lot. More than you might think. I'm kind of glad we put it in degrees. Let's look closely at it. If you want only angles between 0 and 360, that would be 15 degrees, 75 degrees, 105 degrees, 165 degrees, but that's not all. How about 15 plus 185? See? That's 195. What about 75 plus 180? That's 255. That fits in to the 360, 0 to 360 realm. How about 105 plus 180? That's 285, see? There's a lot more that meets the eye. And then 165 plus 180, that's 345. So I can add basically 180 to any of these to produce another 4 answers. So we have 195 to 55 to 85 and 345. Like that. So these are the answers from 0 to 360. So I'm going to just go through this problem again real quick so you can see where we started, because that was a long time ago. Here's where we started. We started by adding 3 and dividing by 4, square rooting. We found ourselves in this situation. So we already know there's lots of answers. There's lots of answers because this shows up all the time on the circle. Plus we're allowing for positives or negatives on it. So we came up with 4 spots on the unit circle where cosine was either root 3 over 2 or negative root 3 over 2. Basically, it's these 4 spots, guys. Okay? And so we wrote them all down, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Then we divided them all by 2 because that was 2 theta, we wanted theta. So we got this list, which we then converted to degrees just to kind of help us understand a little bit. This is the list of all possible angles in the universe that make the original equation true. There are no other angles. These are all of them. We then realized that if we're going to write a list between 0 and 360, we have to be careful because this includes 15 to 75, 105, 165, of course. But starting to add in those 180s, we see we can get other angles to fit between 0 and 360. So for a total of 8 possible answers. I told you it gets harder quickly. All right, what about this problem? Which example am I on now?
6.
Thank you. Example 6. How about cosine of theta over 3 minus pi over 4 equals 1/2? This was not as many answers. It's not even as hard. I just need to do it for you because you might get thrown off by the order of operations. Some people do everything in the wrong order. So, listen guys, if you were given this problem, right, and you were asked to solve for x, what would be the first thing you do? Okay, you could do an LCD. Yes, you could do that. But ultimately, trying to isolate the x, you need to start to get rid of the junk on the left. Would you get rid of the square root first, the 1/3 first, or the pi over 4? You get rid of the square root first, right? The same thing is true here. I've seen so many students add pi over 4 to this equation as a first step. That's not correct. That's not what you would do here, and it's not what you should do here. So the first thing you do is try to get rid of the costs. And to do that, we pull out our unit circle and look for angles that have cosine of a half. That's like our inverting. So we're going to try to find angles that have a cosine of a half. That's our first step. Okay. So find where cosine is 1/2. There's only 2 spots on the entire unit circle where this happens. What are they? 60 and 300, right? Okay, so what we're saying is we're able to get rid of the cost by looking at the unit circle. Don't write 60 and don't write 300. Write pi over 3 and 5 pi over 3. Because you can see there's a pi over 4 there. You don't want to have degrees and radians in the same problem. So we'll just put pi over 3. Don't forget the plus 2 pi k. The other possibility is that it's a 5 pi over 3. Don't forget the 2 pi k. So the first thing I did is look at the circle to find where cosine's a half. Now what would I need to do? My goal is to isolate theta, right? I've got 2 problems to work on now. what would you do next? You gotta get the theta by itself, right?
Subtract.
You gotta get rid of this negative pi over, this minus pi over 4, that's a number. Let's add that over. Okay, so we're gonna add the pi over 4 to both sides. So let's add pi over 4 here and here. Okay, so this becomes theta over 3 equals 7 pi over 12 plus 2 pi k. Let's do the same thing for this solution set and add pi over 4 to both sides. This gives us theta over 3 equals 23 pi over 12 plus 2 pi k. We're almost done. Now we got to get rid of the 1/3. So we'll just triple those equations. So what's my answer? Theta is, if you multiply both sides by 3, don't forget when you multiply you actually distribute, right? It's going to be 7 pi over 4 plus 6 pi k. 7 pi over 4 plus 6 pi k. And tripling the second equation, don't forget to distribute, 23 pi over 4 plus 6 pi k. These are all possible answers. If you want to put it in degrees, you can. Doesn't matter. But be careful with that 23 pi over 4. I don't think that's between 0 and 2 pi. 2 pi is 8 pi over 4. Only the first answer, 7 pi over 4, is small enough to be considered between 0 and 360. So be very, very careful when you answer the second question, find the angles between 0 and 360. You don't want to put too many or too few. Last time we saw we could easily have written too few. This time we can see we'll get kind of carried away. If we start adding 6 pi k's, we're going to be way past 2 pi. So only the one answer there. All right, any questions? You might be asking, well, can my calculator do these problems? Kind of. Your calculator can do this. Your calculator can graph this function. Okay? This is a horizontally stretched, right-shifted cosine wave. That's all it is. Okay? And so it's actually right-shifted by 3 pi over 4. Okay? And it's stretched so that it has a period of 6 pi, meaning it really doesn't cycle very often. It has to cycle 3 times slower than a normal cosine because that 1/3 on that theta. And then you can graph that, graph this as y1 on your calculator. You can see the pretty picture of the cosine. Okay, nice pretty picture. And then you can graph this as y2, just write y2 equals 1/2, and just watch it, it'll go, it'll draw this line. And what you're looking for are these points. See? The problem is the calculator is going to give you decimals for everything, which isn't what we want. We're supposed to be solving with exact values. So those little red dots I just drew, those are the answers, and obviously there's an infinite number of them. And here are the actual answers. 7 pi over 4, 7 pi over 4, plus 6 pi k. And this is the only dot that fits between 0 and 360. It's at 7 pi over 4, which is 315, I think. Yeah, so like only this dot makes it between 0 and 2 pi, because 2 pi is like right here. The other dots are outside this little section, see? So your calculator can do these, but I recommend you not try to use your calculator for this problem, because you're just going to get decimal and not accept it. So you can kind of check your work and say, I only got one answer. Does that make sense? You can look at the picture. Yeah, only one of those dots fit. And then on that last problem, remember the one we got like 8 answers for? Why did that happen? It was because this graph right here, if you look at the graph, it wiggles a lot. So if you look at this thing hits 0, y equals 0, many, many times between 0 and 2 pi. I'll draw a rough sketch of it. Looks like this. It hit 8 times by the time you get to 2 pi. If you can see it, you'd be convinced. So it equals 0, that means it hits the x-axis 8 times. So if you're surprised at your number of answers, I guess you could graph it to see if you're on the right track. All right, and what do you do with a problem where it doesn't look like you're going to use your unit circle? This can happen too. So let me show you one that you kind of need a calculator for. How would you solve this problem? This is example 7, I believe. Is it 7? Yeah. Okay. Yeah, example 7 says, it's the same instructions. It's cosine of theta equals 0.6. How do you solve that? Well, most of us just get out our calculator and type in inverse cosine 0.6. So let's try that. Make sure your calculator is in radian mode. Okay? I'll do the same. Except my calculator's not working. Definitely not working. Let me get my TI-84. Inverse cosine of 0.6 is 0.9273. Don't forget the 2 pi k. Don't forget the 2 pi k. Super important that you have that. Is this the only answer? Listen, guys, the calculator, when you ask it a question like this, it assumes you want an answer from this realm. Right? It's an inverse cosine question now. You've inverted. So the calculator is only going to give you an answer from these 2 quadrants. It's going to assume you mean this point where x is 0.6 on the unit circle, and this is 1. It knows nothing about other places on the unit circle where x is 0.6. Namely, there's another spot right down here the calculator knows nothing about that has the exact same features. See? So there's another spot right here. The calculator will never find it because the calculator doesn't search quadrants 3 and 4 for inverse cosine. It only searches the top, see? So you have to outwit the calculator and say, okay, hold on. It's also true that if I go almost full circle, but stop short by 0.9273, I will have an answer. In other words, if this angle right here, this angle is 0.9273 radians, then the blue angle is 2 pi minus that. So you would do 2 pi minus that to get the other answer. So let's go ahead and do 2 pi minus the answer. Theta would be 5.356 plus 2 pi k. And you have to admit, that is a little tricky. That is a little tricky. The calculator can only give you one of the 2 answers. You have to outwit it and find the other one. Listen, for a cosine problem, anytime the calculator gives you the first answer, just do 2 pi minus that to get the other one. Okay? Let's try a different problem. Still calculator, so keep your calculator handy. What if I said, example 8, solve this one, cosecant of theta is -3. So you bust out your calculator and you're ready to type inverse cosecant, except there's no button. So what do? Well, if we rewrite the question, yeah, why don't we just rewrite the question a little bit, make it a sine question, okay? Isn't this just 1 over sine? Okay. And this just means -3 over 1. So aren't we just looking for where sine is -1/3? That's so much better to think of it that way. So I rewrote the question. This is very common in trig. Rewrite the question if you don't understand it, or if you don't have the right buttons for it. Rewrite the question. And now it makes perfect sense. We're going to be using the inverse sine button, right? The calculator will help us get the first answer. You're going to type inverse sine of -1/3. All right, let's pop that in the calculator and see what happens. Inverse sine of -1/3 is, theta is approximately -0.3398. Why don't we just say -0.340. Don't forget the 2 pi k. All right? Now, the calculator can only give you one answer. The calculator was asked, basically, you asked it to find the point where y is -1 and r is 3. See? And we don't care what this is. So the calculator was able to find that angle right there. But that's not the only point on the grid where you could have a y by -1 and r of 3. You could have that over here too in quadrant 3, see? This is another possible drawing. See? So we got to outwit the calculator. We got to find that one now. If this right here is 0.34 radians, that little subtension, then so is this. And since this is pi right here, I think pi plus 0.34 is also a valid answer. Remember, this is pi, and 0.34 past that, we have another answer. So pi plus 0.34 gives us another answer. Pi plus 0.34 is 3.482. Calculator one's the hardest of all. 3.482 plus 2 pi k is also a valid answer. Now, if they ask you, so these are all answers. If they ask you for the answers between 0 and 360, be very careful. Okay? There are 2 of them. Okay? You cannot go like this and say, oh, if we're going to go from 0 to 360, 0 to 2 pi, it's going to be these 2 answers. You can't do this. Those are my answers from 0 to 2 pi. Isn't 2 pi 6.28? This is 3.14 times 2. How is negative 0.34 between 0 and 6.28? That's not right. Listen, you need to add 2 pi once to this value to get it within range. So let's add 2 pi to that just one time. You can add as many times as you want. We're just going to add it once. This will fall right between 0 and 6.28. So you need to, this is out of range, add 2 pi. If you add 2 pi in your calculator, you'll see the correct answer to this is actually, theta is approximately 5.943 and 3.482. These are 2 answers, the only 2 answers, between 0 and 6.28 that make the equation true. The calculator ones are the hardest ones of all. Okay, they really are, because the calculator, you think you're getting a big boost from the calculator, but it only knows about one quadrant. So you have to like outweigh it, get that other answer, patch it all up, make sure it falls between 0 and 360, and that's challenging, very challenging. I did a pretty hard one for you. I did a cosecant problem, so that you won't have any trouble with my homework problems, I don't think. Okay, this is the end of the lesson, so I'll show you what the worksheet looks like, but this is what's going to be on Edmodo, okay?